is to start by figuring out the interior angles. Because then I can find a supplement without too much of a hassle. So what is the supplement of 88? 92, good. So I start by bringing it inside the triangle, and I get a 92. I do the same thing for 127, and I believe it's 53. So now if you look, this x is what we call an exterior angle. Remember, an outside angle is equal to the sum of the two angles it doesn't touch. So you can do it one of two ways. X is going to equal 92 and 53, so x would equal 145. Or let's say you forgot that, which is completely possible, because sometimes people forget stuff. How many degrees are on the inside of a triangle? 180. So if I take this, I take 180 and I subtract the 145 here, I'm going to get 35, which goes here. Which means that x would have to have been its supplement, and you would still have gotten 145. So you might have forgotten about exterior angles, but you can still get there. Yeah?
How do you get like the 92 and the 53?
Supplements.
How do you
See how they form a line?
Yeah.
That's all. Two angles that form a line are supplementary.
Right?
That's all.
So they both have to equal 20.
Yes, when the two angles together have to equal 180. Yeah. Yeah. Now, what's another thing that I know I have seen on the ACT is exactly the same exact question. And what they do is this. Some form of that. And they were trying to figure out what's x. Yeah.
No, I'm still confused on how you got 92. Would it be
Me too.
60?
They're supplementary angles. Two angles that form a line create 180 degrees. That's it. That's all. Now, what I want you guys to think of this, how many degrees are around the outside of an object? Go all the way around something. 360. So all these would have to add up to 360. This is an ACT question. This is on there. I've seen it before. Okay. So again, back to here. Remember, these two guys are supplementary. These two guys are supplementary. These two are supplementary. That's all it is. You're just using supplementary angles. You do the same thing with the next one. Let's say you forgot about what's called the exterior angle theorem, where that outside angle is equal to the two angles it doesn't touch. So if you remembered that, you'd say 117 is x plus 66. So subtract 66 and you get 51 for x. But let's say you forgot that. Yes, sir? Now, excuse me. Let's say you forgot that. You can do the same thing here. What is the supplement to 117? 63, good. So you can do the same thing where you go 63 and 66, subtract that from 180, and you can still find x. So for most of these types of problems when you're dealing with triangles, whether you're on the inside or the outside, there's going to be a couple of different things that you're going to be able to do. Okay? Close the lid, unplug your earphone, stop playing your phone. You got a test tomorrow. You might want to pay attention. Okay? Thank you. So remember, you don't have to be stuck in one specific way to get there. It's remembering there's more, the old adage, there's more than one way to skin a cat. Never heard that before?
Like scrim sideways. I know, I'm pretty funny.
That was good. I'm surprised you didn't say funny looking, but you know, that'd be mean.
Funny like a clown.
Mr. Murphy?
Okay, good fellas. It'll make you laugh.
Yeah.
Yes, sir. I can't help you with that. Thank you for telling everybody.
Wait, what did you say?
Thank you. I'm sorry that you bit your lip. Maybe if you didn't chew your gum so hard, you wouldn't bite your lip.
Yeah.
Or if you don't chew gum, then you won't be thinking about chewing gum, and then you won't be thinking that you're hungry and want to eat the inside of your mouth.
Ooh.
I got nothing.
Isn't gum great?
How many degrees are inside of a triangle? 180. So in this case here again, you just add them up. 2x, x minus 10, and a 55. You said equal to 180. Hey, what do you think you're going to have with you tomorrow?
Calculator.
A calculator. Good idea. But what else should you have with you?
Progression sheet.
Progression sheet. Okay. So you get 3x plus 45 is 180. Subtract the 45, excuse me, 135. Divide up by 3 and you get what? 45.
Oh.
Okay. Now, the algebra stuff that we're doing here is relatively straightforward. I try not to mess with you guys too much when we do that. So we should be all right with most of the questions we have tomorrow. There's really nothing that's going to hopefully scare you. You'll be fine. We've taken so much time to go through all this stuff, it's not a big deal. We did 4 yesterday, 5 real quick. Why, hello! I haven't seen you forever. How are you? I'm great, thanks.
What's that,
All right,
Scott?
have a good day.
It's a Ruby.
It's probably for your name.
So what kind of triangle is this? It's an isosceles right triangle. Now when you have an isosceles triangle, you know that you've got legs that are congruent, but then that also means you've got base angles that are congruent. If you've got the one angle that's 90, the other two angles have to be the same and also add up to equal 90. Therefore, both of those angles are going to be 45. Good. So all you do is this. And write it out. Guys, I cannot stress the importance whenever you're doing these algebra problems or you saw any of these things up, is that you want to make sure that you write down what you're doing. Because that way I can tell, well, if you make a, let's say you wrote down y minus 16 equals 45 by mistake. You solve for y correctly. Am I going to mark you wrong because you just wrote down the wrong thing? No, because you said an equal the right way. You just accidentally got a minus sign instead of a plus sign. But if you just write down a number without showing me what you're doing, I have no idea how you got that. Okay, I figure it out, but the more work, especially in math, guys, the more work that you show what you're doing, the easier it is for me to assess that you know what you're doing, if that makes any sense. So here all you have to do is just add the 11. We get 56. Cut it in half and you get 28.
How do you know it's 45? Yeah, that's right.
It's a 90-degree angle here. It's isosceles, which means these two have to be the same.
Oh, yeah.
So subtract out the 90, what are you left with?
45.
Well, hold on. You have 180 degrees total. Subtract out the 90, what are you left with? 90. These both have to be the same, so you cut it in half.
Okay.
That's it.
Wouldn't it be 45 minus 11?
No, because how do you undo subtraction?
Never mind. Don't listen. So I get it now.
All right. And then the other one, subtract the 16. What was that, 29?
Excuse me, Kevin. I
I
don't
believe-
think I was talking to you.
So do we just, that was plugging in?
No, I didn't ask you. I just said solve for x and y. And good question. You got to read questions very closely a lot of times in geometry, especially when we're dealing with the algebra stuff. Sometimes it'll say solve for x, sometimes it might say solve for the angle, things like that. So you got to just make sure you double check it, okay? Go good? Yeah. Number 6, I apologize. In order for me to make this work, that should have been more of a straight line. I don't know what I was thinking when I drew that. It was kind of my bad on that aspect. This should have been like this. So we'll say that whole thing's 60. Now, in my mind, when I drew that, I don't know, I must have bumped it or I just didn't catch it when I went to go run it off. So that was supposed to be completely straight.
Yeah,
This
I
one
didn't know
should-
how to do that.
Yeah, you had to have done that to make this work. So I apologize, I didn't catch it quick enough. So that meant that this angle here should have been 60 degrees because of vertical angles. And then these 3 angles form a line. So all you have to do is add the 3 angles together and subtract from 180. So what's 60 and 70? Subtract that from 180, what are you left with? 50, good. So that means that this angle in here was supposed to be 50 degrees, and then here you get a triangle of a 50, 70, and what are you left with? 60. It was supposed to be that, so I'm sorry, don't know how to draw apparently. And I thought I was being fancy because you look, all these things are nice and straight and all that. I used a ruler.
Blood, sweat, and tears.
I got an A for effort, thanks. So
It's gonna take a long time to forgive
You mean you got E for effort?
Oh, he got you there. My mom said when she was in school, you used to get E's. Well, what?
you. In elementary school, you can get E's.
I'm trying to think of that.
Elementary school, elementary school, my mom's old, that's why.
Oh, yeah,
They used to like look at the principal.
I think you're right. I think you're right about you get E's for effort on like do you show effort and stuff like that on stuff.
No, it was like bad, yeah.
No. No, because I mean you could have. I don't know. I mean, grading stuff has changed so many times over the course of many years. I know you used to have 2-tier grades, you know, like a letter grade and an effort grade. That was very common when I was growing up, so that might have been what you're talking about. So you could have had like a P. Oh.
I was in school.
We did 7. Let's look at number 8. Number 8's pretty easy. Once you put that tick mark in there, number 8's really easy. If I put that tick mark like I was supposed to have in there,
Yeah, no, you told us. Wait.
yeah, just the beginning of the hour.
No, yes,
Oh,
you
yeah.
did. Oh, no, you didn't.
If I do that triangle on the upper right hand is what kind of triangle? Equilateral, therefore all the angles are going to be 60. So if this is 60, this is 60, this is 60, which means y is 120, which means this angle is 30, and that is 30 as well.
Sweet.
Yes, sir. Good question. Here's a question. This is a really good question. We'll talk about this more. I forget what unit it is, but you're saying square. You're right. It has 4 right angles and 360 degrees because how many triangles? And then if I do this, that's a pentagon, right? How many triangles are there?
3.
180, 180, 180 by 40. You do 6. 1, 2, 3, 4. 720. So the interior angles go up by each side by putting in another triangle. Word.
Word to your mother.
I was just about to say that. How do you find the perimeter of a triangle?
please.
That would be some of the interior angles. I'm talking about perimeter of the triangle.
Oh, you add up the sides, sorry.
All right, you add up the sides. Now, in this case, what type of triangle do we have? It's equilateral. So we know it's an equilateral triangle because all the angles are the same. Because remember, if they're equiangular, the sides are equilateral. So now, what do I do to figure out the side lengths? Do I set them equal to 180?
No.
No, because they're side lengths, not angles. Angles you could add up to 180. Side lengths you can't.
What do you add up to?
I don't know. You equal to each other. Very good. You have to set them equal to each other because of the tick marks. Now, does it matter which pairs I set together? Not at all. Doesn't matter, whatever. So 2x minus 3 is x plus 5. And then you have a two-step equation. Subtract the x, add the 3, what do you get? No, we don't get whoa, but what do you get? 8. Very good. Now, it says to find the perimeter. Now, is my perimeter going to be 24? No, because I have to substitute the value of x back in. And that's the thing that you have to remember to do. So, what's 8 plus 5? 13. What's 21 minus 8? 2 times 8 is? 16. Subtract the 3, it is. Now, the only reason why I did that for all 3 parts was just to double check to make sure I didn't do something stupid. Okay? So I wanted to substitute back in. Now I add up 13, 13, and 13, and I get a perimeter of 39. Okay. What's up? You get it? No, go ahead, ask. It's okay. Ooh. I was trying to be nice. Jeez. Why are you yelling at me? You are yelling at me.
Nah, if Bella wanted to yell, she would yell.
Okay. Remember, perimeter you're dealing with sides. Interior angles you're dealing with 180. Okay? The only time that the perimeter is going to be 180 is if it actually equals 180. Hey, what should you do in number 10? Make it, draw it out, exactly. How many triangles should you draw for number 10? 2 of them, good. So when you draw this out, you've got 2 triangles. You fill in what you want. AB is 27, angle B is 75, and angle F is 74. Can angle E equal 31?
No.
Why? Good, very good, perfect. This is going to be false because B and E have to match up. If they don't match up, if they actually matched up, excuse me, then it would be okay. But in this case, it doesn't work. There you go.
Fault.
Thanks for keeping up.
I know, I was actually kind of lost. You go,
Don't. Remember, what happened, what we're doing here is, all we did is, we know we have 2 triangles that are congruent. When I have that, your best bet is to draw the picture. When you draw the picture, you fill in what you know. AB was 27, angle B is 75, F is 74. Which means, according to the correspondence, angle B and angle E should match up. They're saying E should be.
oh, okay.
So it can't be, I believe D would have to be 31 to make that work. Okay? $11 we talked about yesterday. I'm going to go down to the, like I said, I was going to try and get down through all the algebra before we do the proof stuff, and then go from there, okay? Hopefully these algebra ones are really easy.
Why did you make these so small?
So they would all fit.
You could have just added another page.
Why?
So that would
You have young eyes. You can figure it out.
I just yawned, I'm not gonna lie.
I wasn't saying you were crying. I was just... Oh, you know what? You could probably do this. You got a phone that you like to use a lot, right?
Yeah.
Can you take a picture of it and like zoom in a little bit? Problem solved.
Well, no, I meant like on here, like.
I know.
Right.
But couldn't you overcome it and adapt it and figure that out?
Well, no, I meant
Up,
like, how
up,
do you
up,
make it?
up, up.
I want to figure out something.
Yes, ma'am.
I have negative.
That's why
It's very like,
See this?
main piano kind of,
And she rolled her eyes and did the head bob at the same time. Well, I'm sorry, Miss Chrissy.
Let me just.
All right.
there was 6 points.
Oh yeah, I should do that for tomorrow. Okay, so go back to the problems here. And just to help out Isaiah, just because, you know, it's fun.
No, okay. What I meant was that like it's harder for
I know.
us to like write in the
I'm messy.
triangle.
I know.
And it's easier for you because you can make it bigger.
I'm messy.
Wow.
So the triangle on the left is relatively quick to work with. It's got a 90 degrees, 30 degrees. What's left over? 60. So this is a 30, 60, 90 triangle. Which means since this angle here has the tick mark, which means the angle L should also be 60 degrees. Now, if you look at it, since this triangle here has the double tick mark, it means it's going to be what type? Isosceles. Good. So it's base angles, sorry, the sides are pointing at the base angles that are the same, which means 3x has to equal 60. X is. Excuse me. Uh-oh. I don't know if I have enough information in the next one, do I?
No.
Or do I?
No.
What kind of a triangle is this? Isosceles. So you have congruent legs, which means you're supposed to have congruent base angles. So what should I write in for angle S? Now, how many degrees are on the inside of a circle? On the inside of a triangle? 180. Good. So you have 3x, x, and an x. It's 180. What's 3 plus 1 plus 1? Very good.
Why?
I was gonna say 4, but it wasn't 4. I'm going to school today.
I believe it's 36, right?
Yes.
I feel bad sometimes if I get things wrong, but I get over it.
For what? I know, but they may not. Because if they got
Last three, again, pretty quick. On 16, you have an isosceles triangle. They give you the vertex angle at 40 degrees. If 40 degrees is your vertex angle, how many degrees are left for these two? 140. So that means that the leftover has to be 140, which means each angle has to equal 70. So 2x is 70. X is?
Wait, how is it?
What's that? There's a bunch of ways. Did you make it? Did you go 2x, 2x, 40 is 20, 46? That's fine. Perfectly fine. I just use it as a shortcut because I know the property. It's what you did is fine. Okay. On the next one, you have base angles are congruent, which means the sides have to be congruent. Very, very fast on that one.
Wait, so the campus is free for everyone? Right?
I think that's what they said.
That's insane.
That's pretty cool.
They're not gonna be able to find a lot of deep
That's hilarious.
unless they're planning on taking it.
Last one, again, some of you guys probably just made it another 3x, added 90 and subtracted from 180. Works the same. But remember, you have an isosceles right triangle, which means what do both base angles have to equal? They equal each other, which means they have to equal.
I was getting ahead.
What I'm asking, what would the angle measurements have to be there?
30.
Try,
60.
try again.
45.
25. You have a 90-degree angle, so if you start with 180, take out the right angle, you're left with 90 degrees. Those two have to be the same, cut it in half, and you got a 45. So 45 divided by 3 is?
15.
I didn't hear you say it. I want to hear you talk again. It's weird. Ah, look at that. No. You just hate me. I know. So funny. Yesterday, before you got, she started talking like crazy. I'm like, what? I'm sorry.
There's like those loud kids in this class, and then everyone's just quiet.
And then there's everybody else that says to the loud kids, shut up, I'm trying to learn.
Yeah, Nigel.
Oh.
Students.
Siéntate, por favor. Gracias.
Yeah.
Haley. Just do it.
Bruce.
Stop talking about it, just do it.
Mi español es legendario. Is that right? ¿Cómo se dice legendary? Legendario? No. Sounds good though. All right, proofs. Again,
Hey, Prue.
what about Hey, guess what? I think you've got like a day left to worry about proofs, okay? So suck it up, you can do it. Yes, sir. I forgot.
Wait, we don't do proofs after this?
No.
I mean, we probably do, but we're just not gonna learn.
I'm hearing everybody say no, so
It is, look it up.
I'm busy.
We're not done with
Oh, I said legend.
I know. People like take videos of me and I'm like,
Hey,
yeah, and
are you mad?
like, she'll be like,
Because you can't tell me any more questions.
I was close. Oh, come on. You know how long it's been since I took a Spanish class? All
Kendall?
Yeah.
Why?
right. Now, guys,
Such pictures.
now right off the bat, when you look at a proof like this, you probably recognize that you've got a bow tie, which meant you might have vertical angles. You also are given the fact that you have parallel lines, which means you might also have alternate interior, corresponding, something along those lines. You also have midpoint. So you've got a bunch of different things you can do here. What you want to be able to do is just start, pick a spot, and go. There's about 3 different ways to make this work. Start with your given. S is the midpoint. QT. So that means when I go to my diagram, S is the midpoint of these two. Does it say anything about S being the midpoint of RU?
No.
No, so can I write anything about
No.
those? No.
Then after that, we should just go to the alternative.
Yep.
All right.
So from there, I'm going to go to my other given. My other given talks about parallel lines. So if I have parallel lines, notice you actually have 2 sets of transversals. So if you follow through, I have angle R and angle U congruent. Can I use one letter for R and U? It's okay because it's the only vertex there. Angle R congruent to angle U. Parallel lines cut by a transversal. Alternate interior angles are congruent. Yes, sir.
What if I just went to the
That's fine. Remember, there's more than one way to set this thing up. Okay? So if you did that before you did the parallels and whatever, that's okay. Because what I'm about to do might be different than what you did. Because like I said, there's about 3 different ways to set this one up. Now, in my mind, I'm seeing that I have another transversal. I can say Q and T are the same. Same reason. Or, you know, if you did it that way, you'll see that you've got angle, angle, side right away. If you did it after you got one set of, if you did R and U, then you had vertical angles there, you'd have angle, angle, side. If you did not, excuse me, if you just did like angles Q and T and vertical angles with the midpoint, you could have had angle, side, angle. There's at least 3 different ways to make these things congruent. It really just depends on how you filled it out. But basically from here, I'm done with what I'm thinking with angle, angle, side. If you put in the vertical angles, that's fine. And then it would have been a matter if you had R and U set up, then it would have been angle, angle, side. If you had Q and T, it would have been angle, side, angle. So depending upon how you wrote it, there's a couple of ways to go about it. But this is a very, very straightforward one. There's no craziness. You really didn't have to come up with anything on your own, except, bless you, except for trying to follow through, bless you, on the parallel lines. Okay? Yes, sir. Do I have to find anything else besides the triangles? Then I don't have to use it. If I asked you to figure out that TU is congruent to QR, then I'd have to do CPCTC. But it doesn't say that. Okay. Here's another one that is extremely extremely straightforward. Basically, everything that's in this one, again, is right off of your progression sheet. Follow through the steps and you should be okay. So, start with what you know. BD perpendicular to AC. That means that happens. So I know now that angles ADB and CDB. Yep. Yes.
Are you serious?
That's what it says on the sheet, doesn't it? Once you have perpendiculars, state your right angles that are formed. After you have right angles, then you say that they are congruent. That's the sequencing.
Oh, no, but I think you meant like ADB.
Wait, can you put
Or you could do like A, B, D.
Is ABD a right angle? No. Where's the right angle formed, guys? At D.
Oh, the.
Okay. So now you've done everything you can from perpendicular. You've got 3 steps to go. Or I'm sorry, you've got 3 steps out of it. Rephrase that. From here, I go to my next statement. My next statement says that D is a bisector of a segment. So it's a segment bisector. What does a segment bisector do? Well, it cuts a segment into 2 congruent parts. So parts. D is bisector of, what was it, AC. So according to my diagram then, I just do this. AD, congruent, DC. What's my reason? What kind of a bisector? Segment. When you're dealing with bisectors, you have to state whether it's a segment or an angle. Okay? You've got a side and an angle. What are you missing? How do you get it? Reflex, that's good. So, what was it? BD, thank you. BD. I forgot what the letter was. There's reflexive. And now you have 2 triangles by, bless you. Bless you. Can I say triangles are group because of that? No, it's not one of my 5. Side angle side. And now you can say those 2 other segments were congruent to each other because of. Here's a little hint, guys. When you have to state that the triangles are congruent and you've already used the lettering for one of the angles, just reuse those same letters. Because you already know that they correspond to one another, so just reuse them. It's a nice trick. That way you don't have to reinvent the wheel. Yes, sir. It's not that big. I mean, that's not that big. And then we got that last one here. What was different about this one is that, yes, it looks like you have a lot of given statements. But as you go through it, there's quite literally nothing that you have to come up with on your own. All you have to be able to do is write down what you have written on your progression sheets, and everything falls into place on this proof, aside from marking your diagram. So as you go through this one, you're given right away that 1 and 4 are the same. And now you have perpendicular. LM is perpendicular to MP. So if I look at where LM hits MP, there's really only one right angle at M. So according to my progression sheet, I now would state the right angles that are formed. Well, in this case, there's just one of them. So I can just say angle M is a right angle. Definition of perpendicular. I go to the next one. OP, perpendicular, MP. And again, if they're perpendicular, a right angles form. Well, in this diagram, there's just one right angle. They're not back to back on each other, okay, like we've had before. So P is a right angle. Now think about it. Do you have two right angles?
Yeah.
What do you know about them? They're congruent. So now you know that you have two right angles, so now you set them equal to each other, or congruent to each other. Okay. Yes, sir.
Is that stuff necessary?
What do you mean?
Stating that they're congruent.
Yeah, 'cause if you don't do that, you can't use them. Even though they're a right angle, yeah, we know they're congruent, but you have to write down that they're congruent. Remember, proofs are so specific. Oh, we're running out of time. So now we've got bisector. So we go through the bisector real quick and fill that out. What is it, MP? So that means MN is congruent to NP. Definition, segment bisector. If I go back to my diagram, sorry about all the steps here, these are the same. So now what do you have? How do we have triangles congruent here? Angle, angle, side. Okay. Angle, angle, side. Angle, angle, side. So your triangles then. And what's that last step then to show those are segments? Just because we're running out of time here, I just want to talk a little bit more. I know that if you go back and think about all the different stuff that we've done, there has to be a good 40 some odd proofs that we've done together. You've got that progression sheet. You've got all this extra little algebra stuff that we've worked through. In the book itself, in chapter 4, there's some extra algebra problems. If you want to look at those, that's fine. But my biggest thing to tell you guys how to prep for this stuff, look at your progression sheet. Look at some of the algebra problems we've done over the past couple of days, and that's basically everything's there. There's no gimmicks, there's no gimmies, there's none of that. Make sure you understand your definitions about isosceles and equilateral, things like that. How do you draw diagrams? It's a very, very, very straightforward thing. Okay, we shouldn't have any issues, to be honest with you. All right. If you guys got questions in the morning or something like that, or something else that you looked at, just let me know. Just pop in. I'll be in here. Thank you. Yeah, I'm here tomorrow morning.
I should have been like, I know.
You trying to pay me off?
Brianna was the one that told me that. She's the one here.
What do you got? Remember, there's extra progression sheets in the back in case you guys want to practice just by rewriting it. That way you know where everything is.
I get so confused.
Oh, I so